company called Alachisoft. We have a product called NCache. Has anybody heard of NCache? So I'm a technology evangelist, and I'm going to talk today about how you can scale entity framework applications with using a distributed cache. This talk is not about NCache. It's about caching. It's about the problems that you guys are going to face. I prefer to have a more interactive discussion, so as I'm talking, if you guys have any questions, please ask them. My name is Iqbal Khan. I'm a technology evangelist at Alachisoft. Today I'm going to talk about how you can scale entity framework applications with a distributed cache. This is an interactive discussion. It's not a lecture. We're going to go through some concepts and go through some source code, and I'd be more than happy to answer questions. Let's make it more of a discussion-oriented session. And we have about 1 hour to do this. Okay. So just a quick overview. I know most of you guys already know Entity Framework, otherwise you wouldn't be here. So Entity Framework is an object-relational mapping engine for .NET. It maps your conceptual object model to your relational databases. Essentially, it simplifies your database programming, so you don't have to do ADO.NET level of programming. You can work at a more entity level, deal with entities, and let the EF take care of the database glue. It's becoming quite popular on the .NET side, and more high-traffic applications are starting to use it. That's why this topic has come up. You work with models and mappings. There's an EDMX file. There's a conceptual model, storage model, and there's mapping. There's object services layer. You have object context, DB context. You can query objects with SQL or LINQ and save changes by working through objects. I'm not going to go into any of that. Okay. Here's a diagram, architectural diagram of EF again. So let's come to the topic. Before we can talk about how you can scale, EF application, let's agree on some terms. So what is scalability for our discussion purposes? It is essentially maintaining a really good performance of an application under peak loads. So if you only had 5 users and your application performed super fast, it doesn't mean that it's scalable. It's only scalable when you have the same performance under 5,000 or 50,000 or 500,000 users. So scalability is essentially maintaining that high performance. The types of applications that need scalability, and they also use EF, especially ASP.NET, .NET Web Services, and any other .NET Server apps. There are other applications that don't use EF that also need scalability. Like if you're doing big data, you need scalability. But for our discussion purposes, we're going to stick to ASP.NET and .NET Web Services type of an environment. So what is the scalability problem that we have to solve through caching? The problem essentially is that there's an application tier that can scale very nicely. You can add more servers to your application server tier. If I were to draw up this picture. So this is your application tier. You can add more and more servers to it and it's a load balanced environment, so there's usually a load balancer up in the front here. You can add more servers as your transaction load increases, but the data storage becomes a bottleneck. And the data storage usually means relational databases or your mainframe data. And if the data storage becomes a bottleneck, then it really doesn't matter how many servers you have in the application tier. Your application is going to choke. So the NoSQL databases do provide an answer to scalability, but most people are not able to move their applications to NoSQL for the entire data. NoSQL databases have their own benefits, which is not the focus of this topic, but in many cases you have to work with relational databases or your legacy data, and that's the
tier that does not scale. So you may be able to move some of your data into NoSQL, but most of it is still going to live in the relational or the mainframe world. So what you do, you basically use an in-memory distributed cache. NCache is just one example. Redis is another cache that is used by Azure. App Fabric has been around, but it's going away now. So the caching, essentially what it does, logically it sits between the application tier and the database, and lets you cache a lot of data. There's some misconception about caching as just an in-proc standalone cache versus a distributed cache. Most people, when they think of a cache, they think of a standalone cache, which is within your application process. It's super fast. So why go to a distributed cache, which is probably on a different server across the network, although it's in the same data center most of the time. And the reason is because if you have a standalone cache, the capacity of that cache is very limited. It's limited to your application server process. And of course, if you have a multi-server environment, you have multiple processes, so that means you need to keep multiple copies of that cache, which will become out of sync. So in comparison to that, the distributed cache is a out-of-process cache. It's a common cache across all processes, and it scales in terms of storage. That you can just keep adding more servers to the mix, and the distributed cache usually pulls the memory and the CPU and other resources of all these servers into one logical capacity. So as you add more servers, your capacity increases, and so this tier never becomes a bottleneck. And because it doesn't become a bottleneck, the pressure on your database is reduced dramatically, because you can cache up to about 80% of your, or take 80% of your traffic to the cache. 20% are usually updates or some fetches that you have to do to refresh the cache. So if 80% of the traffic goes to the cache and the cache is scalable, you can have application tiers that can scale very nicely. And I'll talk from our experience. NCache has been around for about 10 years now, although so a lot of high-end applications use it. We've got customers who have up to 50 or 100 servers in the application tier, so they're servicing a lot of concurrent users, and they are able to do that because the caching tier can handle that load. And usually there's about 5-to-1 ratio between the caching tier and the application tier. So for every 5 application servers, usually you would put 1 cache server with a minimum of 2 cache servers. The reason you want a minimum of 2 is for redundancy purposes and for replication. So if any one server goes down, your cache does not become a single point of failure. So these are just a standard Windows boxes. In case of Redis, these could be Linux boxes, and the clients could be .NET or Java, but for our discussions, they're all .NET. So the cache kind of plugs in. In reality, this picture is not completely true, because this picture implies that you go to the cache and the cache goes to the database. That is called a read-through model. Most people would keep the cache on the side here and go directly to the database, and then whatever they fetch, they put it in the cache. In fact, when we'll talk about the entity framework, most of that is going to be that model where you're going to the database, getting the data, putting it in the cache on the side. So the next time you are looking for that data, you'll find it in the cache instead of going to the database. And cache is orders of magnitude faster because it's all in memory, it's all object, it's a key value pairs, and it's scalable. Any questions up until now? Okay. Here are some scalability numbers that with a cache, you pretty much get a linear curve or line, not a curve, in terms of your read and write capacity. Let me come back to one point about a standalone in-proc cache. So if you had a standalone cache, let's say an ASP.NET Cache object, You would probably get a faster performance than this on a single server box, but it will not scale because of, as I said, the updates are not synchronized. So the out-of-process cache cannot ever be as fast as an in-proc within your application process cache because of the serialization cost and the IPC between multiple processes and maybe across the network. But it is still orders of magnitude faster than the database. And the fact that its scalability is the real key here, that it never slows down. So when people use distributed cache, they use it for three main areas. Number one is application data caching, which is what we'll talk about today. Number two is ASP.NET specific caching, where you can cache your session state. If you have the pre-MVC model ASP.NET, then you can also cache your view state, and you can also put your output cache into this. The third use case is when people use the cache as a runtime data sharing platform. So it's like a pub-sub environment where you can put the data in the cache and use events to asynchronously share data across multiple applications or even across the same application but multiple users. These three use cases have some things in common. Of course, this is all in memory and scalable, which I talked about. But there are some things which are different. So, for example, application data caching, whatever you're putting in the cache, that data exists in two places. One in the cache, one in the database. So a lot of the features that the cache has to provide should be to ensure that that data is always in sync. Because if you are going to have a cache that cannot be fresh, that cannot be in sync, then you're only going to cache read-only data. Your lookup tables, which is what most people think of caching when they think of caching. That's what they think about. That I can only cache my lookup data, but the lookup data is only a small subset, maybe 30% of your actual use. The 70% is their transactional data. So that data exists, and even the lookup data is not read-only. It's not static. It also changes. It may be your product catalog, which still changes maybe once a day or whatever. So you need to be able to sync the cache. So the features need to support that. On these two situations, and especially let's say in the ASP.NET, the cache is the master store. There is no database. When you store the session in the cache, that session exists only in the cache. And it's in memory. And memory is volatile, right? So if a server goes down, you'll lose that session, which may be okay in some cases, but it is definitely not okay in majority of serious applications. If you have a mission critical application, you cannot afford to lose sessions. Imagine if you were just placing an order and suddenly on the last page you had to restart because the server went down, and your session was gone. So the needs for an ASP.NET specific caching are not as much of synchronizing the cache with the database as they are to keep the cache to be highly available. So the data is never lost. And how do you ensure that? You ensure that through replication. So if you have multiple servers, the data should never exist only on one server. Because the theory of fault tolerance says that if there are a minimum of 2 of everything, then the probability of both of them going down is very low. So as long as you can achieve that, you can get pretty close to 100% uptime in terms of your high availability. So, and of course, when the data is replicated to more than one server, then you don't have to worry about the data being lost. And this is not a permanent store. It's a transient data, which means it will exist for 20 minutes, 30 minutes, hour, maybe a day, some small amount of time. It won't exist for years. So that's why so the features have to focus on this. Runtime data sharing is very much like ASP.NET, but it also has to support features which are asynchronous coordination. So the event-driven architecture needs to be there in the cache to support that. Any questions? Okay. So we'll talk about the application data caching, and we'll use EF as the main environment. But our focus is really caching and how what you should do and what is what are the different aspects of it. So here's an example. You've got some .NET code, very simple. You're going to load a customer based on some customer ID. Before you go to the database, you're going to check the cache. And you've got a cache handle because your application connected to the cache. Usually with the cache, just like the database, you connect to the cache and you stay connected. So it's not the HTTP model where you connect every time. Most of the time you just connect to the cache and you keep the cache handle and you'll just use it. So if it's not in the cache, you go to the database, you get your data, and you put it in the cache. So the next time it will be in the cache. So that's essentially the really bare minimum paradigm of caching. The key is something that should be meaningful. It should contain some type, because most of these keys are strings. Most of the caches have string-based keys, and the key should be meaningful. It should have type information, let's say customers.customer_ID the actual value. So, and that's just one example. You can come up with your own, but somehow so that there's no conflict between two different types of keys. So there's a customer that has customer ID 1000 and an employee that also has an employee ID of 1000, that there should be no conflict. So that's how you do it. Now, EF, until EF Core 1.0 has changed its architecture internally, where you can now plug in a third-party distributed cache. But up until 6, there was nothing in EF that allowed you to plug in the cache. That meant that you have to make the cache calls from within your application, like this. So the EF is not taking care of caching for you. There is a way, let's say NCache has also implemented it. There's a way where you could have a custom ADO.NET provider that takes care of caching some of the query results. But that's a query level caching, not an entity level caching. So you don't have as much control over that. So it's better to just make the API calls, whatever caching product you use. Just an overview of what a caching API looks like. You'll connect to the cache. In case of NCache, it is initialized cache. Other caches might have other. So you get a cache handle and you keep it. And then you do a cache.get, get contains, you do an add, insert, remove. Insert means add it if it doesn't exist, otherwise update it. So that's the same as the ASP.NET Cache object paradigm. So very, very straightforward API. Of course, there's more to it than this, but and this is what I was talking about, the reference data versus the transactional data, that you need to be able to cache transactional data. So transactional data is your customers, your accounts, your activities, and most of the time you will need to read that same data about at least 5-10 times within a short period of time. So if you cache it the first time and you save those next 10 trips, multiply that by millions of users or hits that are going to come to your application, and you'll suddenly have a lot of traffic reduced. And because you can have features which will keep this data fresh, which means it'll ensure that if this data changes in the database, your cache will not be old, that you can feel comfortable caching this data. Okay, so if you're going to use caching from within Entity Framework, there are certain things that you need to keep in mind. Again, regardless of which cache you use. First is you need to make all your entities serializable. By default, EF does not make them serializable, so you need to put the serializable attribute with entities. You can actually change your templates so that this is put there automatically, but if not, then you'll have to manually do it. That's the first thing. Second, if you've been using lazy loading, turn it off, because if you do that, then this serialization creates problems. Number 3, if you're using POCO proxy creation, then you need to use this proxy data contract resolver class to map the proxy to actual POCO types. Essentially, what all of this is saying is that you cannot have dynamic types. because you need to serialize them into an out-of-process storage, and then from a different process, you need to recreate them. So if it's a dynamic type, for example, if you have a anonymous type, that's also a dynamic type. Here's an example of an anonymous type. So when you do something like this, there's a type is created at runtime, which is only specific to that process. And if you save that type into the cache, it will get saved, it will get serialized. But when another process tries to fetch it from the cache, it will no longer have that type. So it won't be able to deserialize that into an object form. So you need to make sure that you can, all the types that you're using are concrete types. So there are, I mean, the same issue happens outside of EF if you're using generics, for example, that you cannot really cache generics until you instantiate them into concrete types. So if you have anonymous types, the recommendation that I have is to just create your what I call data transfer objects, just special objects that represent that combined data, and then cache. That way you can cache those objects, and they will be, you'll be able to serialize them easily. Okay. So let's say now that you, so as I said, there are two ways that you can use. One is through the custom ADO.NET provider. EF 7 or EF Core 1.0 is different, although none of the caches are available for the .NET Core yet. But up until EF6, you can either do custom ADO.NET provider or you can do API calls. I strongly recommend that you make API calls regardless, because all the features that you can get from an API call will give you all the control that I'm talking about. If you go with any caching provider model, it goes to the least common denominator. So it'll give you really just the bare minimum get and put features. Whereas you want to be able to do explorations. You want to be able to do absolute explorations for some data and sliding explorations for other data. You want to be able to synchronize the cache with the database. Those are the things that you cannot do unless you have access to the API. And if you're going to cache the data, if you compromise on the convenience factor here, that, well, I'm just going to stick with the provider model, then you'll be forced to cache only data that you know is not going to go stale, which, as I said, reduces the benefit. But if you really want to take advantage, as you've seen, it's not a lot of programming. It's very simple effort to just incorporate the cache into your application. So go with the API. Whether it's NCache or Redis or any other product, go with the API approach. Make the API call. So, for example, if you were to look at this, for permanent data, for data that is also existing in the database, you should use absolute expiration. And I'll show you that. So, for example, I have, for example, I've got this small code. Can you guys see it? Okay. So, you connect with the cache. In case of NCache, all caches are named, and I think same is the case for Redis. So you get a cache handle. Don't do this. This will empty out the entire cache in case of NCache. I don't know why it is even there. Create your object, whatever, and put it in the cache. So you do a cache.add. But you want to use expiration because this object also exists in the database, or it will exist in the database. So you want to use, in case of this, you will use absolute expiration. Right there. No, right there, I'm sorry. Right there. So calendar is a date time. So this is basically saying that keep this in the cache for 1 minute. So from 1 minute from now, expire this, regardless of what happens. Whether anybody uses this object or not, expire this. Because I don't feel safe keeping it in the cache for more than a minute. Because I think if I keep it for more than a minute, somebody else might update this data in the database, and I will have an older copy of the data. So that's absolute expiration does that. Sliding expiration, on the other hand, is what you would do with the transient data. So sessions, view state, other data that does not exist in the database. So because it doesn't exist in the database, there's no need to synchronize anything, right? So, but you do want that when you're done using it, it should go away. So it's a cleanup job, essentially, because you don't want to burden the application into cleaning the data. So that's where you would do the, like say in case that you will do a time span. So it's an interval. You're saying, remove this in 30 minutes. Remove this after 30 minutes of inactivity. When nobody fetches it or updates it, nobody's touching this object for 30 minutes, remove it. That's what you do with sessions, for example. So a session will get expired by default after 20 minutes of inactivity. So sliding expiration is what you do for transient data, and absolute expiration is what you do for this. So what if you cannot estimate how long you can keep things in the cache? Because you can, somebody might change the data in an unpredictable fashion in the database. Yeah. So expirations are done when you can make a fairly reasonable guess of how long it is safe to keep this in the cache. But if you can't make that guess, or maybe you can do expirations, plus you can say, okay, for this data, I will feel safer if I also could somehow ensure that if this data changes in the database, that the cache will immediately be updated. So SQL Server has a feature called SQL dependency. I think ADO.NET also has this as an Oracle dependency, so you can do the same for Oracle. So a SQL dependency, essentially, when you create the object, when you are creating the object, again, when you're adding it to the cache, you just create a dependency with a SQL student. This example is the Oracle dependency. I've somehow misplaced the SQL Server dependency, which I was going to use here. So you specify a SQL statement which represents one row in a table. And you say to, in case of this, it's an NCache, but let's say you're saying to the cache, monitor the database for this row. If this data set changes, remove this cache item, this one, from the cache. So the database now, so you've just added this item to the cache, but at the same time, you just told the cache to now become a client of the database, monitor the database through SQL dependency, which is an event-driven architecture. So the database will notify the cache that, okay, this data set has changed. The cache will go and remove that item from the cache immediately. So the net benefit is that you will feel really safe that your data is never going to go stale. And you can do that with SQL, you can do that with Oracle. And if you have other databases that don't have that feature, then in case of NCache at least, there's a polling-based DB dependency where NCache will poll itself a specific table. So this is a great feature, right? But when you're talking about scalability, this also has overhead, because for every cached item, it creates a SQL dependency data structure in the database. So SQL Server will actually create a data set, or like a SQL dependency data set. So if you had 1 million items and you created 1 million SQL dependencies, guess what's going to happen to SQL? Yeah, it's going to probably die. So you need to, because you're dealing with highly scalable environments where you've got hundreds of millions of items potentially. Sometimes scalability comes with a lot of data. Sometimes scalability means a lot of activity, and most of the time it's a combination of the two. So when you have a lot of data and a lot of activity, then you have problem from both ends. But let's say if you have a lot of data, SQL dependency for that data is not the right choice. So what do? You could do DB dependency, which is polling based. So in one database call, it could probably fetch thousands of rows, and that's a lot more efficient, thousands of times more efficient than the events. Instead of getting those 10,000 events, you're going to just get one database call and 10,000 rows will come back with a key that you have to remove that. So a lot more efficient, right? Not as real time because you don't want to be polling every 2 seconds, but it's probably every 15 seconds or something that you'll poll. But even there, if you've got millions of rows in a table, the indexing of this specific table itself becomes a problem because you're going to issue a query and saying, give me all the rows where this flag is true or something like that. And if it's true and false, then you only have a big B tree of millions of items here, millions of items here, right? So even that doesn't scale eventually. So SQL dependency is the least scalable in terms of amount of data. DB dependency is the next more scalable. And if none of those satisfy your need, then your final option is to do a CLR stored procedure. What do you do in a CLR stored procedure? So in case of NCache, for example, you could actually make NCache calls from within a CLR procedure. So what that means is that you don't you don't create a dependency for those millions of items in the cache, for millions of rows in the database. You actually create a CLR procedure that is called when the trigger is kicked in. And that it calls the CLR procedure to go and update the cache. So let's say if you had a customer object and you've just updated the customer object. So the update trigger kicks in, it makes an NCache call in this case, or a cache call. And that goes and updates the cache with that same data. So now suddenly it's a lot more efficient. Of course, even there, you want to make sure that cache call is an asynchronous call because this trigger is executing within a database transaction. So if within the database transaction, it has to go all the way up to a cache cluster, which has to then replicate and stuff. So your database transactions might start to time out. But a cache that does not provide this feature leaves you really unprotected, in terms of any changes, and you'll have stale data. Now, for a lot of data, you don't need this type of strictness, but for a lot of data, you do. So those are the 3 different ways that I would synchronize the cache with the database. And when you do, please keep that in mind.
I have a question. So earlier we see that when you, first you look up on the cache first, which does not exist, then you basically get data and add it to the cache.
Right.
Now, when you're talking about refreshing the data, so the SQL dependency you create within an NCache, or where do you create an entity framework so that?
So within the entity framework, let's say that you've got an entity that you're trying to cache. So this is that entity. It's that customer entity. Okay. So you're trying to cache it. At this time, when you're caching it, that's when you specify the SQL dependency.
Okay.
So you tell NCache, please monitor the database for this entity, so that if this data changes in the database, you need to either remove it from the cache or reload a new copy. And the reloading of that comes in if you implement the read-through handler. Then the cache has the ability to automatically read the entities from the database. But if you don't have the read-through handler, then at least it will remove it from the cache. That means the next time you look for it, you will not find it in the cache. Then you're forced to go and get the new copy from the database. So, any other questions? Okay. So that is a very important feature. And again, the same rule applies even when you have non-relational databases. You have mainframe data, you need to be able to synchronize the cache. You can't use SQL dependency there, but you can, in case of NCache, it provides multiple ways. There's a file-based dependency where you can use a file as a flag, and if that legacy system updates the file timestamp, then you'll be able to invalidate the corresponding data. Or you can implement your custom dependency, which is your code that gets called every 15 seconds to go and monitor your data source. So let's say if your data source is Azure, or it's somewhere in the cloud. So you need to make some web method calls or something. That's your custom dependency. That's your code that will live on the cache cluster. The cache will automatically call your code, and your code will go and check that specific data and tell the cache, oh, that data has changed. So the cache will remove the corresponding cached item from the cache. So, these are the features. The last one being that when you're, the last one is that Entity Framework deals with relational data that has relationships, one to many, many to many. So how do you manage that in the cache? So if you have a customer object and a collection of order objects, what if you remove the customer object? Is it okay to keep the orders in the cache? Maybe in case of customers, since you don't delete the customers, it's probably okay. But in another case, where you're actually deleting something from the database also, the many side also should be removed from the cache. So how do you do that in a way that the cache can do it for you? Well, again, ASP.NET Cache object provides a feature called cache dependency. It's a key-based dependency. So that NCache has also implemented it. But so that concept essentially, where'd it go? There. So in that concept, you can essentially hold on. Should go here. So let's say that you've got a let's say that you need to maintain one-to-many relationship. So you are going to go and load a customer and all of its orders from the database. And when you're caching it, you want to create that dependency. So what do you do when you put so you've got the customer from the database, you cache it here, it's just a standard cache. Now you're going to go and get a collection of orders for that customer. And when you get that collection, you have two options. One is that you take the entire collection of entities as one item and cache it. Because you don't think that you're going to really need to modify individual entities. For this use case, because again, you need to see from your application's perspective. For this use case, I'm just going to always need this entire collection for the next 1 minute or whatever is my time in which I need to read it over and over again. I think just getting that entire collection is all I need. And it's a lot faster if you get the entire collection as one object, because it's one trip and you get the whole thing. So you put the entire collection. So here's the entire. You put the entire collection as one cache item, and then you create a cache dependency. So that cache item, that collection of orders, depends on the customer. Means that if the customer is ever updated or removed, that collection is also automatically removed by the cache. So you don't have to manage the relationship between the two. The same thing happens where instead of caching, yes, so instead of caching the entire collection as one object, you want to cache every single entity separately, because you think that you might need to fetch the entity as well. There's another use case where you sometimes need to fetch the entity, sometimes you want the entire collection, and why keep two copies of it in the cache? So then you'll keep the customer as one, and you'll add every order object, every order entity as a separate cache item. But now you need the ability to fetch them all as one collection back. So again, ASP.NET Cache provides this feature called tags, that you can associate tags with items. And those tags, then later on you can say, give me everything that has that tag. And you'll get, in one call, you get a collection of those items back. NCache does the same. So again, when you do that, then you can create dependencies against each of those. So when you're caching data from Entity Framework, most likely you're dealing with these types of relationships. And you need to be aware that if you don't create these dependencies, you will have a situation where some of the data that should not exist in the cache will be in the cache, and you'll be reading old data or stale data. So these dependencies ensure that if the customer object is removed, that all the corresponding order objects, either as one collection or every object, is removed. Any questions? These are issues that you deal with regardless of which cache you use, because you're getting data that has relationships, and you need to manage that. Similarly, there's Actually, this example also deals with that. You just need to you're getting a collection of objects. You say, give me all the customers or all the products or something based on some criteria. Again, you've got maybe 500 of these objects. Do you cache them all as one item or you cache them as separate items? That depends on your use case. What you don't want is to cache them all as 500 separate items and then fetch every of them separately. So if you're going to make 500 cache calls, it's better to just go and make one database call, because the cache is not 500 times faster than the database. It's probably 10 times faster or something like that. But so that's where if a cache like NCache provides you the ability to fetch all of them back in one call. So let's say if you get by tag, so in one call you'll get a collection back. So even though you kept them separately, you could get them back as one collection. Any questions? So all of this we're doing to ensure what? That the data that we're keeping in the cache is fresh. So that you can, and if you can do that, that means you can cache every piece of data. Pretty much, like 99% of your data you can cache. 99% type of data, not the entire database, of course, but every type of data you can cache. And that's when the real benefit comes. So when you're looking at a cache, make sure that it has those features. And as I talked about, that to fetch multiple objects back in one call so in case of NCache, it has a bulk get feature. You can also search based on SQL or link. So you can say, give me all the customer objects which match this criteria. Or you could do which we just did, which was get everything that has this tag. So there are multiple ways. There's tags, there's groups, there's SQL query, which has, give me all the customers where customer.city is New York. So in one call, you'll get hundreds of customers back. But again, in one call, just like you go to the database, in one call, you get the entire record set back. Here, you'll get the entire collection of objects back. So the first goal is to keep the data fresh in the cache. The second is that you need to be able to find the data. So you do get, bulk get. If you can't search the cache based on criteria, cache becomes very limiting. If the only way to find data is a key, that means you have to do a lot of bookkeeping to know what keys you should be fetching at this time. Because in a typical application that is using a relational database, you've got a lot of data that from database, you're not always fetching data based on a primary key, right? You hardly, you do fetch some individual, the record that you're going to edit, you do that. But a lot of other data you fetch based on either associations, or based on some other criteria. So you should be able to do all of that from the cache. Otherwise, cache does not have the value for you. And the benefit of a cache is that because it's distributed cache, whatever you fetch, that query runs in parallel on all the boxes, and the results come back. Same thing is that in cache, because a lot of the data that you keep is in object form. In a relational database, you have access to every attribute. It may or may not be indexed, but you still have access to the attribute. In cache, if you don't index the attribute and you try to search it, it becomes very costly search, because you have to deserialize every object to look into it, right? Whether it matches your criteria. NCache doesn't even allow it. The only attributes you can search in NCache are the ones who are indexed. But in a relational database, you can search any attribute. So that's why you need these other features like group, subgroup, tags, name tags, because this way you can essentially create your own grouping or searching mechanisms. That in a database, you would be doing it based on columns. But you don't want to do it based on columns. These are all kept in a serialized form as an object. So in case of NCache, you have a concept of a group and a subgroup. So one group can have multiple subgroups. You have tags, which are just strings. Name tags are key and value. So name tags are good when you're actually indexing text. So in case of objects, every attribute is a name tag, right? There's an attribute name and then a value. What if it's a text? Then there's no attribute. So then you give the attributes yourself. Say this piece of text has these keys and these values. And that way you can search it later on. And all of these, you can, in case of NCache at least, you can search them as part of the SQL statement. Read through, write through is also a very, very powerful feature because if you can let the cache handle more of your data, database access, your application becomes simpler. And also it's like the reuse of code also concept, except that you're doing it in real time in the actual deployed environment. Read-through is a handler that you implement. It's an interface. You implement that interface. You register your code on the cache cluster. The cache calls your code whenever the application does a get and that item is not in the cache. So instead of saying it doesn't exist, it'll call the read-through and say, please go and get it from your data source. And then it'll cache it and give it back. The interface looks very simple. For example, here, so for example, if I had here's a read-through provider. In case of NCache, you just implement this interface, iReadThrough provider. It has a load from source method, init method, which is you just call once and it connects to your data source, dispose method, which it at the end of the database, and load from source basically takes a key, and you give it the key, and it gives you back a cached item. So it goes to your database and reads the data and gives it back to you. And then you being the cache, it gives it back to the cache puts it in the cache and gives it to the application. Now, read-through itself is then used in another situation, which was, we talked about expirations. So when the data, if you're saying that I don't feel safe keeping this data for more than a minute in the cache, well, why remove it? Why not just reload a new copy automatically? So you can, in case of NCache at least, you can combine the two features and say, when this expires, instead of removing it from the cache, please just reload based on this read-through. And that way your cache becomes self-sustaining. Write-through also, sometimes it's okay for you to, if you're updating the cache, you want the cache to go and update the database. Sometimes you want the cache to update the database in an asynchronous, in a background method, because your application does not want to wait. You have performance implications, and you don't want to wait for the database to be updated. You do want to be notified if it fails, but you don't want to wait. So that's where the write behind comes in. It's a queuing architecture, which essentially the cache gets updated immediately. It's super fast, and the database portion of it gets queued up. And again, it's not as simple as it seems, because whatever you queue has to be replicated now because of the high availability. And especially you're updating, so there's sensitivity here because you don't want to lose that update. So in case of NCache, for example, at least, it replicates the queue to more than one server. So if any one server goes down, you don't lose the queue. So none of the updates are lost. But the auto reload is a very powerful feature. You can use it on expiration, and you can also use it with database synchronizations. So when you've done that SQL dependency and the corresponding data in the database has changed, well, reload it automatically. So the cache takes care of all of that. I've talked about this already. I'm not going to go into a lot of detail, except that a good cache needs to be fast, of course, otherwise it's not a good cache. Both NCache and Redis are very fast. It needs to be scalable, which means as you add more server, the incremental capacity needs to be a linear thing, and both NCache and Redis are scalable. It needs to be also highly available, so that not only is the cluster totally dynamic, so that you can add or remove servers at any time, but there's partitioning done that's automatically readjusted. That's where NCache really shines. But your cache needs to be able to handle partitioning in a dynamic fashion. So you don't have to worry about which data exists where. You just add a new server. If a server goes down, it automatically repartitions. Let's say if you had a 3-partition cluster, one of the partition goes down. Well, this partition is no longer there. So the replica now needs to become active. So it becomes active, and now it needs to merge itself with the other 2 partitions, because if you only have 2 servers left, you should only have 2 partitions. So all of that should be done automatically for you at runtime. It's not as simple as it's may seem, but a good cache should do that, and NCache does do that. Some of these features are done by others also, but not in the same capacity. Client cache. So client cache is a feature that gives you the best of both worlds. So, I talked about the in-proc cache within the application process being super fast because it is your application process. It's in an object form. It's kept on your heap. What could be faster than that? So, but the limitation was it's not scalable and it doesn't synchronize. The client cache gives you that cache on top of this cache cluster, and it automatically synchronizes itself with the changes. So you get the performance of an in-proc cache on top of the scalability of a distributed cache. Some people call it near cache. We call it client cache, but the concept is the same. It's a local cache on your application server within the application process, but it's kept synchronized. It should be WAN replication. I'm not gonna. So there's some comparisons of NCache versus Redis. If you are going to actually use NCache, a cache, and if you're a .NET focused company, you need to look at the options. So NCache is definitely there, and so is Redis. So you should do a comparison of the two. NCache has been around since 2005. It's the oldest .NET cache with lots of features. I think that's pretty much the end of my talk. I still have about 5-7 minutes. I'm just going to quickly show you our website. So here's our website. Company name is Alachi Soft. The word Alachi is a Hindi word. It means a spice. It's a cardamom. So actually, the actual word is Ilaichi, but we just spelled it that way. So NCache has been our flagship product, but we also have recently launched a NoSQL database for .NET. It's a fully sharded NoSQL database. Any questions?
Kind of about data cleanup in terms of you have it disposed, in terms of does NCache offer a solution of scalability in terms of we're running on a cache space, it's going to clean up itself, like in terms of drop off, or like trying to keep track of, do I have to keep track of all my cache items basically?
No, not at all. In fact, in case of NCache, so there's expirations, there's cache dependencies, SQL dependencies. So that's a way to essentially remove data when you think it's no longer safe to keep, right? But there's another feature in NCache called evictions, which when the cache reaches whatever size you have allocated in terms of memory, let's say you said, I don't want the cache to consume more than 4 gig or 10 gig, or our typical configuration, by the way, is 2 or 3 servers, 16 gig each in memory. So let's say if you have a 16 gig box and you've got a partition replica, so you're going to have 2. So you'll have about 6 to 7 gigs per server as a partition. So that's, let's say 7 times 3 is 21 gig, multiply that by 2 because of the replica. So that's how much storage you have in terms of the cache. When the cache reaches close to that maximum, it will automatically evict. And in case of NCache, we have this least recently used algorithm, least frequently used algorithm, and a priority FIFO. So you can pick and choose. So you never have to do the cleanup yourself. Evictions will kick in only when there's no more storage space left. You can turn off evictions also. So in case of sessions, let's say you don't want them to be evicted, you'd rather reject new sessions than kick out existing ones. So you can do that too. But in most data, eviction is when it kicks in. You don't want to depend on eviction as the only source. You should expire or do cache dependencies and essentially keep data only as long as it makes logical sense. But if whatever you do, if the capacity was maxed out, then NCache will automatically clean up. Go ahead.
I was just wondering, how you do your architecture. So you have like properties that say, in your getters and setters to check the cache first in there, and then if it's in the cache, return from the cache. And do you do your logic in that type of pattern, or what type of pattern do you do?
The most common pattern is just do cache.get. If the object doesn't exist, you'll come back with a null. That's the fastest way. You can do a contains also. So you can say do cache.contains. It comes back with true or false. But a null is also false. So that's the pattern. Just do cache.get.
We're talking about partitioning, right? So this is something, who is creating partitions? Is that something maintained internally to NCache?
Yes.
Yes. As externally, we don't need to worry about.
Yes. So you just need to know that this is the architecture that NCache has. It's all dynamic. It's all partitioning, automatic. All the partitions, all the replicas are automatically created for you. You don't even have to have the replicas. Let's say you can also have just a partition cache where you don't feel like you want to use up the extra memory for replication. Let's say if you have memory issues. Most people don't because memory is so cheap. You'd rather not lose the data. Even if it's in the database, it takes a lot of effort to reload it. It has a performance hit. Let's say if a server goes down and now you have to reload that 10 gig of data from the database, it's going to have a performance impact. So people usually go with the partition with the replication. But it's all done automatically for you. Good. Thank you very much, guys. Appreciate your patience.